Hello and welcome. This video will go over how to do the Geartrain lab, where you have a system of gears that you crank manually and it ends up turning a fan. Okay. So yeah, the first thing we're going to consider with this, so this lab is basically teaches us a number of things. It teaches us how to model gears in SOLIDWORKS, but kind of more importantly, it teaches us how to model to tolerance to design the tolerance for bearing seats. Okay. So yeah, we got to consider a number of things about what's going on. For one, I'm going to be giving you some ball bearings, all right, and I'm going to be giving you some shoulder bolts, which are the shafts effectively that the bearings will ride on. Okay. Every one of these shafts is going to have two bearings. This paper here is what I'm using for a lot of the information on my report. I would recommend checking it out. It's very good. But one of the first rules is usually you put two bearings on a shaft, so that's what I've done here. Okay, and we'll skip through a lot of this stuff that's not really super important to us. For what is relevant here, we have to consider how we are mounting this bearing. Okay, so normally you have basically two seats for a bearing. You have the shaft seat where the shaft goes in the inside diameter, which is called the bore, and then basically the outside diameter of the bearing has to sit in some sort of housing. Okay. And believe it or not, one of those fits or both are going to be made as an interference fit. Okay, meaning the thing that is supposed to fit inside of, so basically whether it's the shaft in the bore or the outside diameter of the bearing in the housing, one of those is at least one of those is going to be an interference, meaning, if you're talking about the outside diameter of the bearing and the housing would have a smaller diameter than than the bearing that it's meant to go inside of it. Okay, meaning as you push it into the material, there's going to be a force that's sort of clamping or holding your bearing in. Okay, so yeah, what we have to consider is how our load is going to be transferred. Okay, so with our gear train here, I have an example of the gear train. Basically, we'll be rotating these gears, and based on the tooth angle of the gear, we're going to consider a normal force onto the shaft, and that's always going to be acting in one direction. Okay, uh, and the bearing housing in this case are going to be the individual gears. So you can see, hopefully, you could see that somewhere in there. There's a bearing that is inside of that gear. Okay, and the gear is obviously spinning. All these gears are spinning, and they're all basically have the same pressure angle and everything like that. So. For our circumstance, we're going to have a load that is a constant direction with a bearing housing, the outside diameter of the bearing is the one that's going to be moving. Okay. So what we want to do is have the outer ring have a tight fit and or interference fit, and the inner part of the ring have a loose fit. Okay. So basically our shaft should be able to very easily go into our bearing. Okay, but the outside diameter of the bearing should be pretty hard to push into our housing. Okay, so yeah, taking a look down here, we have certain classifications. We have the lowercase numbers here that have to do with the interface between the shaft here and the inside diameter of the bearing. So again, this diagram here, you have the bearing, you have the shaft down here in light gray, and then you have the housing up here in sort of darker blue. Okay, and you can see these green lines represent like the exact dimensions of like your bearing slash housing. All right, so if you have an interference fit, basically the reds are for interference fitting, and then the orange is like transition, where depending on where you are within that tolerance, it might be a light press or have a little bit of clearance. And then you have the ones that are in yellow that are, unequivocally clearance fits. Okay. Um, so yeah, next, we have to take those considerations for how the load direction is. All right. And let's talk about the tolerance classes for these shaft seats. All right. So all these tables are from your ISO standards. Okay. And yeah, that's what we're going to be utilizing to sort of check what sort of dimensioning we have for our stuff. All right. So we have ball bearings and roller bearings. Okay. And we want the inner ring to be easily displaced. Okay. Meaning, we want our shaft to very easily slide inside of our bearing. So what it recommends is a G6. All right, so we're gonna go with that consideration for our condition. Okay, because that satisfies what we want. All right, so now we'll go down here. So here we have tolerance classes for cylindrical slabs on axial bearings. We don't want that. We want the radial bearings. So that's why we did the first table. Now we have housings for radial bearings. Okay. So again, we're going to go with the second one down here, the circumferential load on outer ring or indeterminate load direction. We have the circumferential load on the outer ring. So we have rotational forces around the outer ring, which is, obviously what we have in our gear train here. Okay. And we are going to consider this a very low load. All right. Basically, we are just going to crank this by hand, with the hand crank here. So I'm going to consider that a low load, very low torque. Okay. So we're going to consider that K7. So the capital K means that it has to do with the housing. Okay. So let's take a look at what's going on here. So what did I say? It was G6. So let's just go up and double check. So we make sure we have G6 and lowercase g6 and uppercase k7. Okay, so here we go, g6. All right, and the diameter of our shaft happens to be between 3 and 6. Okay, it actually ends up being 5 millimeters. Okay, and it's saying that the standard bearings should be either right on dimension or at worst 8 microns undersized. Okay, so 0.00 the yeah 0.008 millimeters. That's 8 thousandths of a millimeter undersized. Okay, so yeah, now we could take a look. Um, G6 set, basically it's kind of confusing here, but there are two of these columns, okay? The -4 to -12 tells you that if you have a shaft that falls into these G6 considerations, it should be somewhere between minus 4 microns undersized, all the way up to 12 microns undersized. Okay. Um, and it's saying that at worst case scenario, maximum material condition for both the bearing and the housing. Okay, so let's say maximum material condition means you have 8 thou undersize for the bearing, and you have only 4 thou undersize for the shaft. Okay, that would be 8 minus a -4, which would give you 4 thousandths interference fit. Okay, so and that's why it's bold, because it's interference. Okay, and then you see up here on the upper end, okay, in the sort of least material condition. So that means the the bearing is right at the nominal dimension, which according to this chart is the maximum material, sorry, the least material condition. That's the largest hole. Okay. And then you have -12 here on the shaft. So that's when the shaft is very small. Okay. And so that's when the shaft is as small as it can be and the bearing is as big as it can be. That would mean that you have 12 thou clearance. Okay. But really, this thing is saying that you want to be between 1 thou of clearance and 12 thou of clearance with a shaft that is between -4 thou and -12 thou, and with a bearing within this categorization. So what I want you to do, so I'll have a bunch of bearings that I buy, okay, and each one will be slightly different, right? They'll fall within this tolerance categorization. You need to find a shaft and bearing combination, and you'll use calipers to measure this, or micrometers, and you want it to be so that you fall between 1 micron of clearance and 12 microns of clearance. Sorry, I might have called it thou before. It's going to be a micron is a thousandth of a millimeter. Okay. So yeah, measure your specific bearing and shafts that you get, so that you could hopefully, cater, tune the shaft and bearing combination to reach to achieve the 1 micron to 12 microns of clearance. Okay. Which is what we're going to want for this particular one. All right. Okay, so now we'll scroll down and we'll go to housing fits. Okay, and if we remind ourselves from before, we want K7 for our particular seat. Okay, so we'll scroll down to K7 in the housing fits. There it is. Okay, and we have a shaft diameter, as you can see. This is for the shaft diameter of 6 to 10. Okay, inclusive of 10. So we're looking in these first two columns, and we're going to go down to K7. Okay, so what we have here, K7, basically the housing deviation can be, it says +5 micron oversize or -10 micron undersize. Okay, gives us a pretty big range, and that's for the bearing outside diameter being exactly at tolerance to 8 micron under tolerance. Okay, so again, in the worst case scenario where you have the greatest fit, okay, you would want it to be up to 10 microns of interference. Okay. If you have the worst condition where you have, the largest housing, okay, and also the so largest housing being 5, okay, and then the smallest shaft, okay, sorry, and then the smallest bearing being -8, 5 plus 8 equals 13, okay, so that'd be 13 microns of clearance, okay, which is what we do not want, okay, so really we want to stick between 10 and 2 and 10 microns of interference, all right. So yeah, where do we want to be in between that range? So to figure that out, we're actually going to back this up with an equation here. We're going to consider for this equation that the diameter of the bearing is in fact its nominal diameter. Yeah, we need to be somewhere in between the 2 and 10 thou. And it's unclear as to exactly how big to make your housing. Okay, so to find that exact answer, I've made a MATLAB code for the equation that you find in your lab manual that tells you the del. So del equals 2.5 times square root of FR times lowercase d over uppercase B. Okay, so yeah, we're going to consider the FR to be 200 pounds. Okay. And that's just because that's what I'm going to specify to you guys. That's how much holding force I think will be necessary for what we're doing. Okay. So we're going to plug in 200 pounds. You'll need to convert that to the correct Newton's force. Okay. And then, yeah, basically you plug in your diameters and your bearing width, and you're able to get your del. Okay. For this particular case, I am getting a del we're gonna call it like around 8 microns, okay? And I'll leave it up to you guys to get the to do the actual math, okay? And certainly that eight microns of interference falls neatly between the 2 and 10, even up a little bit more towards the 10. So yeah, that's what we're gonna use the equation for our final guidance as to what we're actually gonna make the dimensions. Okay? So now we could take that information and we could go to SolidWorks and we can start designing our gear train. Now, after we've selected our seatings and everything like that, we are now going to figure out how to make our gears. Okay, so what I'm going to do first is I'm going to go to get a new document. Let's bring that over here. So we're going to do a new assembly. So we're going to actually start with an assembly. Click OK. Any second now. There we go. So now we are making an assembly. we're not going to actually add any parts. It's going to prompt us to open something, but we're just going to not do that. We're going to start on front plane or, whichever plane really. Uh, and what I'm going to do now is let's just draw a center line. Okay. And this will go from here to here. Okay, we'll make this horizontal. All right, and then we're going to make two circles that will represent sort of where our gears go. Okay, in order to get it to be properly spaced. Okay, so yeah, I'm going to make. So we're going to end up making an 18 tooth gear and a 72 tooth gear. So we're going to call this. Um, 18 if it's if it's mod 1, then we can make this 18 um millimeters, and this is the pitch circle. Okay, and I have it in inches now. I'm just gonna quickly go to millimeters. I'll have to go back into the sketch, so sorry. And then this one is going to be 72 millimeters. Okay, cool. And there we have it. All right, so now we will exit this sketch. Okay, we're actually gonna do use the SolidWorks toolbox. Um, so we'll go, which one is it? Toolbox here. So it's the one with it's in the design library. So yeah, if we go into toolbox, so yeah, have to add it in, add that in. So it basically makes you do it every time you log in, or sorry, you open SolidWorks. So let's go down. We're going to go to anti-metric. Okay, we're going to go to power transmission. We're going to go to gears, and we're going to go to spur gear. Okay, we're going to drag this one in. Okay, usually puts it in on the wrong spot. So we're going to make it module 1, number of teeth, 18. Okay. So again, yeah, what that'll mean is if you have module 1 and you have 18 teeth, then the diameter, the pitch diameter ends up being 18 millimeters. Okay, so pretty simple math. That's how we'll end up doing it. So now we will hit escape, and let's just line this up with what we want. Okay, so we're gonna do assembly, mate, and hopefully it lets us do it. We're gonna make it concentric with that center point. Okay. Break other mates to satisfy it. Okay. Sorry, it's only telling us that because this is fixed because it's the first part in there. So I'm going to right click and float this. There we go. Now it took out the errors. Let's go back to made it. And I just want to show you guys how it sort of lines up on the circle that we just made. There we go. And there you can see it's like outer teeth kind of go a little bit farther than that 18 millimeter circle that we made, but that is the pitch diameter. Okay, so yeah, let's add another one in, and I'll slow down a little bit and show you some of the other features. Oh, sorry, I think I got to get out of the mate thing, and then I'll add another spur gear in. So we're adding another spur gear. Should be able to drag it in, yep, and then it will prompt us to make it a different gear. So again, I could change the number of teeth. Pressure angle, I have a couple of different options for that. That's the like kind of angle that the teeth are pressing against, each other. So basically, that angle determines how much sort of radial load goes into the shaft. Okay. So yeah, it would end up being the sine angle, or yeah, it's related to the sine angle of the pressure. Yeah, the sine of the pressure angle, I should say. Okay. And you could program in a face width here and a hub style. So you can make it yeah, you can make one-sided. Yeah, so you can make a hub like that. We don't really need that, so we're gonna have none. So if you wanted to make like a collar on it, yeah, we're not gonna use exactly that feature, but we are gonna use them to get our involutes. So this shape is kind of complicated in how you have to like you know, how you have to make it for every different size. So like, yeah, on the bigger gear, this curve here is going to look flatter than it does on the smaller one. And you'll see what I mean in a minute here. So instead of the number of teeth 18, we're going to do 72, which is four times that. Now, it's a general rule of thumb. A lot of times you do not make a gear ratio more than 4 to 1 for spur gears. Okay. The reason this is a rule of thumb. Like I'm sure like certain gearboxes are designed with greater than that ratio, and I'm sure a lot of things can get away with it, but you have to consider, the fatigue of one gear versus the other. So if you make one very, very, very small, it's going to see a lot more fatigue wear than like say the bigger one. Okay. And it will wear out much, much, much quicker because it's, basically distributing its lifetime load on fewer gear teeth. Okay. So yeah, no, normally like your general rule of thumb is 4 to 1. I'm sure there's more derivation behind that, but we're not going to go into that right now. We will click check on this gear. And now I want to basically show you, we could hit escape. We don't need another one. But I could basically show you, I'll mate this one to that other sketch. And I'll show you how these gears like sort of meet up. And we'll make that not coincident, but we will make it, why doesn't it want to make it concentric? I don't want that. Okay, let's clear. Can I go on the inside bore? And that, no, it's not letting me. Let's try the inside bore once more. Yeah, face one. There we go. Now it's done it. And it'll let us do coincident. Or sorry, concentric. So there we go. And now we're just gonna make this face and this face coincident, but the other way. Flip it around like that. There we go. And click check. Okay, so now I'm not going to do a gear mate just yet. I don't really need to show you what I'm trying to show you. So it looks like as these things meet up, they have some designed backlash in here. Okay, which is correct, and that's like how these gears should be in their normal tolerancing, which is good. And you could also see what I was talking about before. This curve here looks much more like a straight line than this curve here. Okay. And that's because, yeah, as the gear gets larger, that gets flatter and flatter. And on a rack, that is an absolutely straight line. Okay. And it has to do with how these two surfaces interface. And basically the line of action that goes through like that basically is tangent to both faces has to, stay at a consistent angle. Okay. And that has to do with your pressure angle. All right. And if you don't have a consistent pressure angle like that, then you're going to have undulating forces. Okay. So if you have basically two square pegs that are interfacing as a gear, then that pressure angle is going to be changing quite drastically. So yeah, the reason why you have a curve on one and not the other is so that as they're rotating, the pressure angle remains consistent, and therefore your torque transmission remains consistent. Okay, cool. So we have our gears. All right. These are actually the only two gears we're going to have this guy generate. But we are going to use these to make a couple of other gears in our gear train. Okay, so let's start out with the first gear, which will be the compound gear. So I need a couple of things from this guy here. So let's hide those sketches just so that they don't annoy me. I'm going to click this surface here. We're going to click sketch. Okay. Doesn't really matter whether or not I'm in the assembly or in the part in this case. Actually, I don't think I can modify the part. So yeah, never mind. We're just going to make a sketch in the assembly. And then you're going to click the front face so that it's highlighted blue like that. And then you're going to click convert entities. There we go. So now, as you can see, is it made that like all those guys it basically outlined our gear tooth. Got all those guys in there. Okay. I'm also gonna wanna, yeah, I probably want to get that one too. or convert those entities. So I clicked the edge of that circle and then I clicked convert entities and it made it a sketch line. Okay. So pretty simple. I'm going to make a separate sketch so that it's like, deliberately different. So we're going to again click on that surface, make another sketch, and I'm going to do the same thing to the other gear. I could have clicked that face to start a sketch on. It doesn't really matter. We're going to do convert entities once more. And yeah, there we go. Oh, and the inner edge convert. Okay, cool. So now we have both the inner circle there, which we'll use just for centering, and the outer edge for both of these. Okay. So now what I'm going to do is I'm going to go into a new part. So I'm going to go to File, New. I'm going to make a new part file. Okay. Do that. Okay. And then I'm going to make a new plane. Okay. Front plane. Come on. Sketch. Okay. And now I'm going to go control, well, here, sorry. I should copy them first, right? So let's go back to the gear. We're going to go to the sketch 2 first. Control C. Then we're going to go back to this part 2. We're going to control V. Okay, great. So yeah, now we'll highlight all those entities. We will go to move entities, and then we're going to try and zoom in, and we're going to get the very center point of the whole thing, and then we should be able to move this whole thing around. Zooming all the way in to the origin, make it coincident with the origin. All right, and then I'm just going to take all this whole thing, and we are going to show the selection, and we are going to fix it. Okay, and then once it's fixed, it's fully defined. I'm not going to go about dimensioning all that. I would don't hate myself that much. So, anyways, going to exit the sketch, and then we're going to go and extrude this. Okay. Now, the shoulder bolts I bought, these guys in there, their shoulder length is going to be 12 millimeters. Okay, 12 millimeters. So that is what I'm going to go for when it comes to the overall width of all these parts. Okay, so for this middle gear in here, hopefully you guys can see. Where's my camera? So the middle gear in here is like a compound gear. So it has as you can see, like a smaller gear on the back and then a bigger gear on the front. Okay, smaller gear on the back interfaces with the crank gear. That is the one that you end up rotating in order to spin the fan. So yeah, but anyways, the width of this gear should be 6 millimeters because that is half of the width of the other one. Okay, so 6 millimeters. Okay, and I'll also change my dimensions. Okay, PSI, millimeter gram second. All right. Then let's get the other sketch and we'll put it in here directly on top. So I'll sketch on the top surface there. And let's go and grab the other profile, which would be sketch 3. Control C. Going back over to our compound gear, or what will become our compound gear. We will control V. Okay, cool. So we have our sketch entities there. Let's again highlight them and we will go to move entities. And then we'll again, let's make sure we get the very center. Yep, get in the center. And then we will go to our origin, plop it right in the middle there. And again, we are going to fix those guys there. Are you fixed? There we go. Yep, fully defined. And we'll exit sketch and we'll go to extrude that. So now we're in the boss extrude, and again, we will make this one 6 millimeters, just as we did the other one. Okay, so extruding that 6 millimeters, clicking check, and as you can see, we have a compound gear. All right. But we need to do several things to it. Okay. So first off, let's yeah, we'll end up doing this with some cut extrudes. I could make holes with Hole Wizard. Yeah, but I'll just end up doing everything with cut extrudes. So let's make our 2 diameters on this surface. All right. So what I'm going to do is I'm going to make our larger diameter first. Okay, so if you remember from the beginning of this video, the nominal diameter of our bearings is 10 millimeters, but we have our del, which is the amount of interference that we want to get. And again, we calculated that and backed it up with what we saw on I kind of think well with what we saw on the ISO standard tables. Okay. Wow, that was a mouthful. So we're gonna subtract 0.008 millimeters. Okay, which is I think it was 8.2 was what the actual dimension was. So anyways, we'll do that. It ends up being, yeah. What does that end up being? Do my math for me. Okay, yeah. 9.9918. Cool. So yeah, we'll be able to hopefully measure that with calipers. I think probably the printer will have the resolution for that. It's close to yeah, it's close to like like 5/10,000ths of an inch. Uh, it's pretty small. Okay. Anyways, next we'll hit exit. Oh no, wait. We'll make one more circle. Now this circle in the middle here is very simply just going to be clearance for a shaft. All right, so we're just gonna go and make this 6 millimeters. Really, as long as it's like a little bit more than five, it's gonna be just fine. The shaft, being the shoulder bolt, is a 5 millimeter diameter. So if you make it six here, it'll have clearance and that'll be just fine. Okay, so now we're gonna exit this sketch. We're gonna go to extruded cut. We're going to make sure, let's go down to selected contours. We're going to make sure that it's just the middle one. Okay, and that one is going to go through all. Okay, so the middle one goes through all. Check. Okay, let's quickly show that sketch because it will hide it as soon as we do that. So now we're going to do uh, um, another extruded cut. We're going to grab the outer dimension of that circle. Uh, yep, that's doing that. Instead of through all, we're going to go blind. The length of the bearing is 4 millimeters. Come on. Okay, so we could go in like that. Yeah, so there's a couple ways we can do that, but yeah, we'll just go in 4 millimeters. And then really simply, we will go ahead and we will mirror that last thing that we made. So if you go right up to mirror, which was up here, it's now gray. So after you make the cut, you go up to mirror, and then you should be able to, it should automatically select the last thing we did, which was the cut extrude. All right. And then we're going to mirror that around this face. Okay. So as you can see, it looks like it wants to make that cut for us. And indeed it does. Okay, so now we have your interference fit pocket on one side and it's mirrored on the other side. So this is where the two bearings are going to sit. All right. So yeah, next we'll go on to making the next gear in the Geartrain set. All right. So here we are. We're gonna prepare to make the crank arm here. All right. So what we're gonna need to do first is we're going to need to utilize the larger of the two gear profiles. All right. So really quick, we'll just grab the second one, Control C, or yeah, sketch two, I should say, and then we're gonna go and we're gonna make a new part. Okay, go in and we'll make a new part file. Click OK. And wait for that to open up. All right, we have a new part here. Okay, so once the part is opened up, you could go into the front plane, sketch, and we're just going to go Control V. All right, cool. We're going to again highlight like we did before. We're going to move entities, and we're going to make sure that the middle point is indeed at the very origin, and it'll give us that coincident. Okay, great. And then now we're very simply going to highlight everything, show the selection, and fix it once again. Okay, now what we're going to do now, so we're going to extrude this, but we're going to extrude it just to, instead of doing 6 millimeters, we're actually just going to do 5. Okay, so we want this to be a little bit smaller than the other gear, or then I guess I should say the pinion gear on the compound gear. So basically, so that they don't rub against each other, or indeed the sides of our like sort of fixture for it. Okay, so we're again going to go to features, extruded boss base, and we'll extrude that. We're going to do 5 millimeters rather than 6. Okay. Um, yep. Okay, cool. So now we have that on there. So yeah, we could do a number of things like we did before. I can sketch onto this surface, all right, and we will make our two holes for the bearing pocket and for the clearance hole. So we'll start at our origin, we'll come out, and we'll do that once again, making two circles. So one of them we're gonna make since the shaft diameter is 5 millimeters, we're gonna make the clearance hole for the shaft whoops, that's too big. 6 millimeters. Okay. And I am in inches now, so you know what, let's get out of here. Let's change it to millimeters and let's go back into the sketch. So back in the sketch, we're gonna make the outer one. That's gonna be that 10 millimeters minus 0.008 or 8 micron. I think it was, yeah, 82. And we'll do that. Okay, and that'll be our bearing pocket. Okay, cool. So we have those now. So actually, you know what? Before we do our cuts and everything like that, let's draw our other geometries. Okay, so what we're going to need to do here is we're going to need to create a crank arm. Okay, and the way we're going to do that is we're going to extrude like basically a tube, and then make and then make like a little handle assembly, or not assembly, make a little handle for it. So yeah, now making the crank. So first thing we're going to do to make the crank is we're going to sketch on the front plane there. We are going to draw a circle here, and it's going to be 15 millimeters. All right, so bringing that out to here. This one here is going to be 15 mm. There we go. So that's 15. And then we're going to do features, extruded boss base, and we're going to try 50 millimeters there. The one in the model that I showed you earlier in the video had 60 on that length there, but I don't really think we need it to be that long. I think we'll still have the clearance, but of course we will double check everything for when it's time to do it. Okay, so now we can click check on that one. All right. And now it's going to be time to do now we're going to have to make like sort of an oval sketch that'll allow us to offset our crank arm, so that we could actually spin it around. So, yep, to do that little arm offset, we could say we're gonna go and sketch on that surface. Okay. And then we're gonna grab this guy over here, which we haven't done in a while, which we haven't done ever, I don't think, is gonna be like the sort of slot tool. A lot of different ways to make a slot in SolidWorks. But yeah, you could do it with sketches. So I'm gonna come out, go to the center line there, come out, and then we'll bring that guy outward. So we're gonna make a couple of relations first, or I guess just one. So we're gonna shift click the outer edge and then that circle, and we're gonna make them equal. Okay, great. And then we're gonna make this um, 30 millimeters. Oops, not that. Make the length of that 30. Okay. You don't want to make it too long because like as it sits in the stand, you might be able to like you might like hit your hand into the like kind of ground, I guess. But if you're holding it, I guess it doesn't really matter. So, putting 30 there is what I thought was like a relatively sensible amount. Okay, cool. So now we're going to let's exit the sketch. Sorry, let's make that full screen again. Exit the sketch. Okay. And now we are going to do extruded boss base. It doesn't, I guess, really matter which direction I'm going to go, but I am going to go, I think, into the material. And we're going to go instead of 50 millimeters, we're just going to go 5 millimeters. Okay, cool. And then I'll make sure I merge the results so that there's not two separate bodies. So yeah, that looks good. Okay. And now what I can do is we're going to make the like sort of finger holder for the handle. Okay, so I'm going to find the plane that goes across that slot that I just made. For me, since I made the way I made it, it ends up being the top plane. So I'm gonna go ahead and sketch on that top plane. All right, and now it's gonna be helpful for me to see that last sketch I made. So I'm gonna go to the Boss Extrude 3 and go to sketch 4 and show it. Okay, so that I can snap onto various points that I have. All right, so now yeah, I'm still in sketch 5. Good. So now I'm gonna grab a center line. Okay, we're gonna come up from there. Okay, and out from there. All right, so now actually I don't think I need to make that for construction, so we'll just make that a solid line. And now we'll start putting our other geometries in there. All right, so we'll go like that. We'll go like that. This one I'm just going to kind of freehand and not reference anything that I've done previously. It should be relatively easy to do this. So you could come over there like that. Going to go coincident with the line I made previously. And now we're going to let's make some dimensions. Okay, so again, we're just kind of freehanding this. It doesn't have to be anything in particular, like some of the other dimensions that you made. So let's make this, um, I guess we can make that, let's make that just 10. Okay, cool. I want to make this so that it doesn't look as weird. So let's add some relations. So I'm going to make a center line just so that I can add a vertical relate or a tangent relation. So we're going to come here and we're going to go shift click the line and that arc. Okay, and we're going to make that tangent. Okay, that looks a little bit weird. And then now we're going to come over here and we're going to make this guy um, to there. I think I will make that 7.5 just so that it can be, as I revolve this, it'll go all the way to the edge there. Uh, and then that honestly looks kind of weird. Let's see what we could do to the diameter here to change things around. So we're going to make that 2 millimeter radius. That looks kind of weird. And then, but let's see what it looks like after we do this. And then we can make that 20 millimeters, like 3/4 of an inch. All right. Looks a little bit weird. You know what? I don't think I need that tangent relation. Um, but well, let's see how that looks. Honestly, that should honestly work fine. You could be able to hold it in your hand and everything like that. So you can make something like that. Again, it doesn't have to be exactly that, but something similar. And then what we're gonna do is we're gonna do a revolve boss base, and we're gonna select the first line that we made, and we're gonna revolve it around. So you can see this is like just something to hold on to so that you could actually crank the gear. Okay. So we'll hit check on that. And that looks like it's gonna actually be just fine. I'm not gonna change that at all. Okay. Now, we need to start doing our holes for our bearings and stuff. So we made that sketch on the bottom. I guess I could have just done the cut extrudes there as it was, but it's nice that I've made the whole geometry so I can make that one, the smaller one, go all the way through. So let's do extruded cut. We're just going to do the simple one first. Take that one, and we're going to go through all. Okay, cool. And there we have it. So now we'll go back, we'll do the drop down from the cut extrude 1, and we'll make sure we show that sketch. And then what we're going to do is we're going to do another cut extrude. We're going to select the outer geometry, and then we're going to have this one go blind to 4 millimeters, because that's going to be where how thick the bearing is. All right, cool. So now what we're going to do, we have that through hole all the way up there. We're gonna go back and we're gonna make actually another sketch on this plane. I guess we could do a couple of things, right? We could add to the initial sketch that we have that we use for that boss extrusion. But we could just make a different sketch. You could do either or. It doesn't actually really matter that much. So we're gonna do a couple just one sketch, one sketch entity from this sketch. You're gonna come out. You're gonna go out to here. Okay. And we need to make clearance for our bearings. Okay, so we have 10 millimeter outside diameter bearing, and so we're going to make this 11 millimeters. Okay, so decidedly bigger, so 11 millimeters, and then that'll allow us to push our bearing, all the way to the portion where we want it to be pressed in. Okay, so we're going to hit exit from there, and then we're going to extruded boss base. Okay. Oh, sorry, not extruded boss base. Sorry, cut extruded cut. And then we're gonna do it. So we're gonna do instead of blind, we're gonna do uh offset from surface. And, excuse me. Sorry. And then so yeah, we know we want the bearing uh to the like top of the bearing to be at like where the like bottom of the head for the shoulder bolt is. So this is going to end up being 12 millimeters away from that. Okay, so there we go. That's 12 millimeters away from that surface. Excellent. And then we'll hit check there. Okay, cool. Now the last thing we're going to do is we're going to sketch on that surface, and we're going to make a a sketch entity that's there. And again, this is going to be uh 10 minus 0.0082 because that's what we had calculated. All right, cool. And that's our circle. And then now what we're going to do is I'm going to extruded cut, and we're going to make that one go just 4 millimeters because that's the width of our bearing. And let's see. Oh, blind 4 millimeters. Sorry. There we go. And you can see that goes in there. And perfect. So we do a section view cut. So section, and let's do not that one. That one? Yeah. So you can see just what it's doing on the inside there. So we have like that portion of the bore. Let's click check. We have that portion of the bore, which is just clearance so that we could like sort of slide our bearing down into this portion, which is like so in that portion, one of the bearings will be pressed, and in that portion, the other bearing will be pressed. All right. So we'll take our section view out. And so that looks pretty good. So we're gonna name this so gear crank or whatever you want to call it. This one's for the video, so I'm calling it video. Okay, so we're going to save that. All right. And that honestly looks pretty good. So yeah, that's all we're going to do from this one. The next thing we're going to be doing is the gear fan. All right. So again, after we have done our compound gear, our crank, it's now time to do the one that has a gear and a fan on it. Okay. So what I'm going to have you guys do, first of all, the fan looks a little bit daunting. Okay. I'm going to give you guys the fan. All right. It's important that you see how the fan is constructed, however. So let's just quickly go through the tree view, and I'll just suppress a lot of things. Okay, first started out with a peg. Okay, and then what I did was I created this wrap geometry, so you can see that there's like a thin line there. Okay, that wraps around that particular cylinder. Okay, I derived this part from an axial flow pump that I had designed with velocity triangles. I've simplified these sketches so that it's a little bit easier to modify. But basically, you make the wrap, and then you extrude a thin feature. Okay. Oh, sorry. You make the wrap. for that one. And then this thin feature, so we can show it. Basically, I made this other like really really thin geometry so that I can do another projection like I did for the first one. So I'll go ahead and hide that. And then I make a plane. You can see that plane two is tangent with that thin extrude. All right. And then I do the same thing with that other one, right? I make another wrapped geometry with this particular sketch. Okay. And then I extrude a thin feature. Okay. Another one at the final diameter. Okay. I make another plane. Okay, and then finally another sketch and wrap combination. Let's show that final sketch. Okay, so we have those sketches. Okay, and you can do a number of things for this one. You can modify, for instance, the diameter at which the thin extrude exists. So I made the middle one at 75 millimeters. If I really wanted to, I could change that to like 50, okay, which would make it sort of equidistant. So let's hit rebuild on that one. Okay, cool. And as you can see, it scooted that other one up a little bit. Okay. Um, yeah, and it's really up to you how you manipulate this geometry. But I want you guys to try and do some sort of geometry modification. All right, as you can see, whoa, that looks a little bit weird now, but critically it still works. So yeah, this would be fine if I really wanted to use it. But what I might do is I might reduce the length of this one just a little bit. So yeah, this is meant so that you can basically just pull, push and pull at different dimensions. Um, it looks like I might want to make this one a little bit. So I made that equal to dimension 3 in sketch 6 over 2. Okay, so that's the 70 there. So we're gonna hit X out of that. And so we're just gonna get that one and we're gonna go, I don't know, 50 or something like that. Uh and then we can move everything around so that that particular one is in the middle. Okay. So why is that not doing 50? Okay, so we can move that one to there. We can make that one. How come it's not doing D3 over 2? Interesting. Should be doing that one. So let's click sketch. Oh, okay, there we go. It rebuilt it. So sorry, it took a minute to rebuild what it should have done and made it central. Yeah, so basically now I could tweak some things. I could even tweak the angle that I have at the entrance and the exit. So I have 15 and 17. I could make those bigger or smaller. So if I made that more pronounced, I might want to make it a little bit more exaggerated or whatever. But right now I'm going to make it a little bit more of a relaxed angle than my first one. Okay. And then I'm going to change this one from 15 to, I don't know, 12. Okay. Just to show you how you can do it. And then I can make this one also, I can make this one 13, whatever. Okay. So yeah, you'll go in and you'll modify some of these sketches so that you could make the fan pitch whatever you want. So yeah, I could hit escape from that. And as you can see, that's my that's my wacky geometry. Yeah, I wouldn't normally make a fan that's like shaped like that. I don't think it would be very efficient. But yeah, normally you want to have a more severe angle at the roots with a lot of impellers or propellers. Usually want your pitch at the root to be higher and the root being closer to the hub, the center of the rotation. And then out towards the end, you want it to be sort of a little bit less angled. Okay. And that's so that you could have the same meridional velocity, which is the velocity that's kind of going along the direction of the axis at varying diameter. So you want, the velocity to be the same whether or not you're in the middle or towards the outside or whatever. But you guys can make it really whatever you want. So just like, yeah, kind of have fun with it like I was doing. That looks just fine there. Okay, cool. So that's our small fan. I'm gonna file save this as small fan, and then we could do underscore video. Okay. And uh and that's what we're gonna do here. All right, so now what we're gonna do also is we're gonna make a small pinion gear. Okay. Oh, well, before I leave here, we're gonna double check a dimension. Um measure. So I've made that 11 millimeters. Okay. And that is so that the bearing can slide nicely through it. All right. Now we're going to make a separate part now that'll involve us making this pinion gear. You could honestly make it all in one part. I kind of like to do them separate so that I have a nice clean piece of paper, and then we'll find clever ways of combining them later on. Okay. So yep, let's go to new part. Okay, we're gonna get a part out. We're gonna do okay on that. Okay, great. And then now we're gonna go on the top plane. We're gonna sketch, and we're gonna go back to our gears here, and we're gonna grab the pinion. I don't think I ever defined pinion. Pinion is very simply just the smaller gear in the gear train. Okay, so now we're gonna go to this guy, the unnamed part. Okay, we're gonna, again, as we're in this sketch, we're gonna hit Control V. And then now what we're gonna do is we're gonna move it around and just make sure that it is at the origin. And we're gonna go to the midpoint there, or the middle point, I should say. And then we're gonna come back to the origin just to make sure we're coincident. Probably didn't need to do that, but anyways, go in there, highlighting everything, and we're gonna make all those fixed. Okay, just like we've been doing. Next, we will extrude this. We could extrude this um to the 6 millimeter thickness. So we're gonna go extrude above space, and we're gonna make this 6 millimeters. And I've forgotten to change my dimensions once more, so let me do that. Millimeters, grams, seconds. Okay, great. And then now we're gonna, pretty similar to what we were doing before. Let's do, as always, do the two. Well, actually, let's change this up. Let's change this up a little bit. We're gonna actually come out and we're gonna make a spacer profile. Okay, so really, we could make this at whatever diameter we want, really. But this is just creating an offset because the way it's going to go down is the crank gear is going to basically sit right up against the surface for its like for the gear fixture, let's call it. So the thing that's going to hold the gears in place so that they can rotate relative to each other. Basically, the first gear, the crank, is going to go kind of almost directly on the surface of our fixture. Okay. And then what we're going to do is we're going to have that attached to the compound gear. So the pinion of the compound gear is going to be meshed with the large gear on the crank. Okay. So then what's going to happen on the compound gear, the large part of the compound gear is now going to interface with the fan gear. Okay. But that larger gear is going to be 6 millimeters off of the surface of the of our fixture. Okay, so basically on this gear, I need to make a little spacer profile. So I need to make like a kind of, I guess, shoulder, if you will, that allows us to do that. So let's dimension this one. We can make this one. We'll just make it. Yeah, we can make it. I guess I could make it 15 if I wanted to. Yeah, that'll just barely get us on the inside of there. So yeah, why don't we do that? We'll make it 15. Okay. And then I'll escape that. And then we will extrude that to be another 6 millimeters. Okay, cool. And again, we're doing all this based off of the shoulder bolt dimensions. Okay. So now we're gonna go ahead and we're gonna sketch on this surface, and this is where we're gonna do uh the two profiles. Okay, so we're gonna go from there, come out, and again go from the middle, come out, and now we'll dimension them. So this guy here will be, of course, our 6 millimeters, so that it's just clearance for our shaft. And then this one is going to be, of course, our famous 10 minus 0.0082 millimeters. Okay. And that'll be for our press fit. All right. There we go. Now we're again going to go extrude a cut. We're going to define the geometry. so that we have, so I'm going to clear those selections and I'm going to click on the on that one. And this is the one we're going to make 4 millimeters. Okay, there we go. That's the length of the width of the bearing. And then we're going to do another extrude cut and we're going to have that guy go. Come on. Why is that not letting me do it? I guess I need to show the sketch. That would probably help. Okay, there we go. And what I'm going to do now is select, I'm going to delete that and I'm going to select, okay, let's go ahead and show you. Oh, welcome. How come it's not showing? There we go. Taking that middle one and we're going to go, instead of blind, we're going to do through all. Okay, great. And yep, there we go. So now what I'm going to do, quick little trick, just so that we don't have to boss extrude. It might not even be that much quicker, but I'm going to make a plane on that surface. Coincidence to that surface. All right. And wait, did I even need to do that? Okay, yeah, I needed to in this case, but yeah, anyways, make a plane on the on that face that's like kind of cutting the or splitting the gear from the little cylindrical geometry we just made. So yeah, we make a plane there. I'm going to do mirror, all right, and we're going to mirror about plane one, and we're going to mirror the cut extrude. Oh, features to mirror the cut extrude. Oh, not that cut extrude. Sorry. Delete. We're going to do the one before. There we go. So now we have the bearing pocket on either side. There we go. Okay, cool. So that's our small gear. So we're going to call this pinion gear uh video. Okay, cool. All right, great. So now we'll save that. Cool. And you know what? Now what we're going to do is we're going to create our first assembly. We're going to make a big assembly with all the gear and everything like that. But then we're gonna make a with the whole with all the gears. But we're gonna make a sub assembly with this gear and and the fan. Okay. And from there we'll be able to do a couple things. So let's go file, new, and then we're gonna do assembly. Okay. And then we're gonna put both of those guys that we just made in there. Okay, so fan small for the video, and then we're gonna do insert components, pinion gear, for the video. Okay, great. Cool. And so yeah, what we're gonna do is we're gonna go ahead and mate those. Okay, we're gonna go from there to there, and those are gonna be coincident. Is that the correct direction? Oh, wait, no. No, 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 no. I screwed that up. I don't want that one to be that one. I want to be that one. I want those two to be mated so that the gap or like the spacer, I guess we could say, is at the bottom. Okay. Gonna click check on that, and then we're gonna go that surface and that surface, and yep, they are concentric. All right, great. So that's what we're gonna do there. As you can see, oh, that rotates independently. So we're gonna do that and that, and we're gonna lock them together. Although it won't really matter, I guess, in the other assembly that we make. But yeah, that should be good. Um, okay, cool. So that should be more or less it. Oh, and let's save it so we can make this gear fan video. Okay, there we go. And so yeah, the next thing we're going to do is we are going to prepare our part that will basically serve as our connecting body for all of our individual pieces. So yep, that's what we will do next. All right. So for our next step with the Gear Fan Lab, we've finished our fan and gear assembly. We've put these two together. We will add bearings in a little bit, but for now I wanna go ahead and and make the actual fixture for what we're gonna attach all these gears to. Okay, so let's go. We're gonna go and we're gonna open up a new document. We'll make it a new part. And let's go ahead and we will make our stand. All right, so first we're gonna just make a quick rectangle that will allow us to make sort of the vertical component of where the gears are all going to be sitting. Okay. Um, so yeah, let me just reference some of my previous dimensions that I had. Uh, so we're gonna go with on the top here, we're gonna make this. We can make it 145. Okay. 145 millimeters. And yet again, I've put this in inches and I'm doing things in millimeters, so bear with me. And then we're going to make this 25 millimeters across, and that should be good. So now we will exit that sketch and yep, let's make sure we change it to inches, pounds, seconds. Okay. And then now what we're going to do is we'll extrude it and we'll select that one and we will extrude it 10 millimeters. Why is it not did I not change it? There we go. Millimeters per second. That should change now. Okay, cool. So now we have our stand. The next step is to make the base for it. So I'm gonna go here, I'm gonna sketch on the bottom. Gonna go to sketch. All right. Instead of starting from the origin, I'm actually going to start from the midpoint here, and we're just going to make a quick construction line going across. And now we're going to go and do a midpoint, a center rectangle. We're going to click the midpoint of that sketch line, come out from it. So my previous design was a little bit small for this, so I'm going to go a little bit bigger. So I have it as 100. So there's 100, and then I had the other dimension here as 50. Okay, but I'm going to have this one actually be 75. It's going to be a little bit bigger, and I might not be able to fit everything in one build platform, but it'll be worth it because the base will be just that much more stable, and we could check the center of gravity of everything to make sure that it's not going to topple over. Okay, and then we'll go here and we'll extrude that 10 millimeters as well. Okay, great. Um, so now it's time to put our holes in. All right. So let's do that. So we're gonna go ahead and we're gonna sketch on this guy. Okay. Um, so yeah, let's make sure we go in and do a sketch. Okay. And let's go and do a center line coming up from the bottom. Okay, we're gonna make this guy go to there, go to there, and go to there. So I have 4 segments. Okay. Um, let's quickly we're gonna make that one, shift click that one, and that one all equal. Okay. Now we have our 18 tooth mod 1 gear and our 72 tooth mod 1 gear. So that means the pitch diameter of the small gear is 18 millimeters and the pitch diameter of the large gear is 72 millimeters. Okay, so this distance of this guy here is going to be 18 plus 72 divided by 2. And then that one here is also going to be 18 plus 72 divided by 2. Okay, so these two together should add up to 18 plus 72. Therefore, so we're going to go from here to here to that point there, and we're going to call that 18 plus 72. Okay, and it ends up being, sorry, 18 plus 72 should be 90. There we go. And as you can see, that brings us kind of nicely to the top here. Yeah. So now we have a space to put our holes. We're gonna do tapped holes. And yeah, I guess in the future I should really be doing um some thread inserts, but for now we're just going to keep these as tapped holes. Let me just quickly reference which one, which size I use. So I use an M4, okay? So that's what I'll use again with this one. So yeah, we're going to make these M4. So we're going to go into Hole Wizard and we're going to make these instead of half 32. Let's make it metric. We're going to do M4 and we're going to do through all, sure, positions, and we're going to do these three locations. Okay, great. And we'll click check on that. Awesome. So now we have our through holes. Now we're gonna do something a little bit clever that I didn't do previously. And that is we're gonna do like a little bit of an offset bump on all of these holes that will allow us to sort of offset our gear train. Okay. There's probably a couple ways of doing this. I probably could have done the bump out a little beforehand. But either way, what I'm going to do is I'm going to go and I'm going to sketch on this face here once again. And we're going to just draw a couple concentric circles. So one that starts there and ends there, another that starts up here and ends there. Okay. And then we're going to go again to there. Okay. So yeah, basically we're making little spacers here that are kind of built into the part. Oh, I don't think I grabbed the center point of that. There we go. And okay, oh, and the last bigger circle. Okay, so now I'm going to shift click the outer ones. Okay, and I'm going to make these larger than the bore diameter of the bearing, but smaller than the outer diameter of the bearing. Okay, so we're going to make all these equal. We're going to dimension them to be we could make them 9 millimeters because it'll be less than our 10 millimeter one. Actually, let's make it 8. Make it considerably less. 8 millimeters. And then we are going to also shift click the inner ones. So holding down shift, clicking all the inner ones. Okay, and we're going to make those all equal. Okay, and then now still can move it. So we're just going to make shift click that one and that one also equal. And yep, now we should have a fully defined sketch. Great. All right, so now we're gonna hit exit, and we're just gonna need to extrude this like really just 2 millimeters for all these guys. Yep, so all those little guys are doing that. We're gonna do instead of 10 millimeters, 2 millimeters. Okay, and this makes it so that as the gears are whizzing around, they don't sort of rub up against the side there. Okay, so yeah, it makes it a little bit smoother, hopefully. All right, so that goes to 2 millimeters. Now we have our spacers, we have our tapped hole. We are looking pretty good. Now all we really need to do is make it pretty and do a fillet around everywhere. So I'm going to go to the fillet tool here, and we're going to select. Will it let us? Why is it not letting me do that? Let's see. Will I do? Oh, that's because the radius is way too large. We're gonna do like a 3 millimeter radius. Let's see if I do that. Yeah, that looks pretty good. Although 3 millimeters is probably way too much. Let's try 2 millimeters. That looks a little bit better. All right, and let's go and try and select all the faces. Okay, that looks fine. There, that also looks fine. That looks fine. And can I get that one and that one? Okay, and that looks like it's doing it all. I'm just going to click there. All the services that I can. You know what? I'm not going to click the back surface because I don't want it to fill it on the inside there. But I'm going to click those two services. And just make sure the top is filleted too. Yeah, that looks pretty good. Do I need it coming up there like that? Probably not. Let's just make it, okay. Yeah, you know what? That's fine. That should be just fine. It's not going to rub on the gear. All right, cool. So that makes it look good. And we have our stand. So I'm going to call this gear stand for the video. All right. So now we'll save that. So great. Now that we have this one done, the next thing we're going to do is actually go uh to the main assembly, and we're going to start putting everything together. Okay. So let's go to File, New, and we'll go to Assembly, and okay. Okay. Let's put our stuff in here. So we have the gear fan video. We're gonna need the stand. We're gonna need the yep, so let's just put those two in there for now. Those guys. And then we're gonna go to insert components. We need to browse, and we're gonna get the crank for the video. All right, cool. And we also need the compound gear. And then so let's do that. So browse compound gear small video. Yep. Open up that one. All right, cool. So now we can start placing all this stuff in here. Uh all right, so first thing we'll do is we will mate the bottom of this guy to this face. So wait, that's the oh, that's the fan one. So the fan one will go on top. So those two will be concentric, or sorry, coincident. Check. And then we're also going to do that and make it, yep, concentric. So coincident and concentric, and that should be what we need. As you notice, they're like not quite touching. And that's fine. You know what? Actually, yeah, I'm gonna undo that last mate, and let's put the bearings in first. So I'm gonna give you guys the bearings. So let's delete that one. Uh yes, I'm sure I want to delete that. Okay, so deleted that one. Let's put the bearings in first. So I'm gonna go and we're gonna insert some more components. We'll just do one at a time, one bearing at a time, that is. So I'm gonna go to my downloads. I will give you guys this uh, ball bearing. This is not the exact ball bearing that I used. Okay, this one is a model of a bearing that's from McMaster-Carr, but it is like the same exact size as the one that I've been using. So let's make this inside inside here. So I'm gonna go make this one and this one concentric. Okay, great. And then let's see, can I take that one out of there for now? Actually, you know what? I don't probably need to. I could just click that surface there. Okay, good. And I'm also going to click that surface there. Okay, and then they are mated. So I've seated that bearing in the pocket. So good. And then we're going to go, we'll get out of mates for now. And let's copy a couple of those. So Control C. So we're going to need 5 more, right? V, 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 V. Okay, so a total of 6. So let's mate the rest of those in there. So doing mate. I might choose to do a time lapse for this. I'm not sure. Maybe it's valuable to have the whole thing, but yep, doing a concentric and doing a coincidence mates. There we go. Okay, cool. So now we have 2 bearings in there. All right, let's just keep going and do all the other ones. So that one goes in there. Click check. And then that face goes against that face. Check. Looking good. And then we're going to do that one. And then finally that one. And then, oh, did the wrong one. Why won't it let me move it now? Control Z, sorry. Now we'll try that again. I need to do that face with that face. There we go. Now that bearing is seated. Perfect. And then finally for the crank. So we're again going to put that guy in there. Good. Nope, no, don't want to hit that. Want to delete that. Just trying to move the bearing out to get that face. There we go. So, coincident. All right, cool. So great. We got all the bearings in there. And now we can start putting all these onto their fixture positions. Okay. So we're gonna put that guy there. So we're gonna do that one and make sure that they are concentric. All right, great. And then now we're gonna do the same for this one. So that face needs to go up against that edge, and we'll make sure that the dimension is flipped around. Okay, that's good. And then we'll make that one and that one coincident. Okay, cool. And as you can see, yep, those gears look like they're going to interface. We will show you how to do a gear mate as well, but I'll do that in a little bit. We need to do a couple more steps before we do that. Next, we will continue to mate all of our surfaces. So that one and that one, flipping that around. Good. Check. Now doing concentric, that one and that one. Good. Check. And we can see that we have clearance there, a very little bit, but that is good. All right. So yeah, now we have all those in there. Okay. Couple more things I want to do. Next, what we're going to do is we are going to find the shoulder bolts. After we've added our bearings, we can now add our shoulder bolts. Okay. If you check in the shoulder bolt library here in under all your the toolbox under bolts or yeah, bolts and screws, and then you can find your socket head screws. And we're going to use a socket head screw in our assembly. Annoyingly, if I drag this in, I can show you. Even like the smallest size that they have is still bigger than the M4 one that we're going to need. Um, so yeah, that's kind of annoying. We're not going to be able to get down to the M4 that we need. I think this is a 6.5 millimeter shoulder, and that gives you an M5 by 0.8. So yeah, that's just barely too big for what we need. So when that happens, I usually just download something from McMaster-Carr. So again, I'll give this to you as well. And that happened with the bearing too, annoyingly. The SolidWorks preloaded stuff didn't have a small enough one for what we needed. So let's go, sorry, instead of that, let's go to Insert Components. We're going to go to Browse. We're going to go to Downloads and, oh, the shoulder bolt. So we get the alloy steel shoulder bolt. And I'll give you guys this as well. All right, so what I'm going to do is let's go into here. Let's click, no, not that face. How am I going to do this? I'm going to go to this face. Okay. And I'm gonna mate it with this bottom face, I guess. Yeah, I could do the bigger gear first. So that one and that one. So basically this face is the face of this gear I know is right up against my little spacer. So I'm kind of using the face of the gear. It's going to be right up against the spacer directly, but I'm just clicking the face of the gear just because it's easier for me to click on. So we're gonna make that one coincident, yes. We're gonna make that one be uh uh concentric inside there. So let's see. Yep, we got that. And yep, we indeed have clearance around it, so we should be just fine there. Might even be able to make that inner diameter a little bit smaller if we really wanted to, but I'm going to say that's fine. So yep, let's copy that two more times. The shoulder bolt that is. Uh, yep, copy two of those. I'm now going to mate both of those. So mate. Okay, we're going to mate that one and that one so they're concentric. And then I'm going to also mate um, the bottom edge there. And then I think we could just barely get away with snagging that bottom face there. Okay, great. Okay, cool. Nice. And if we really wanted to, I guess we could put a washer there. I'm not going to put it in this assembly because, yeah, I mean, I guess we could put it in this assembly, but yeah, not really super necessary. And make those two concentric. And then we're gonna, okay. And now we're gonna click on that bottom guy, the bottom edge or face. I guess it doesn't really matter. And then we're also gonna get that bottom face as well. Okay, cool. So let's hit check. Let's why don't we do a quick little section view? Oh, I need to click on a mate and then I could do a section view. Not that plane, that plane. Okay, and I can see, yep, all my bolts and bearings. So I got bolts and bearings for all that sort of stuff. And it looks like they all fit nicely. Those who are just butt up against each other. Let's go out just a little bit more. There we go. That's our section view. Okay. Something's bothering me about that section view. So let's X out of the section view. So I think the first component, which is fixed. Okay, yeah. So let's float that component and then I like to always go ahead and mate the two origins and align axes for the first part and the origin of the assembly itself. So I grab the origin of the assembly and I go to the first part here in the tree view and I grab the origin of the first part and I make them coincident with axes aligned. And then, I like that because then it's like in a good spot. And then when you do a section view like this, then it's perpendicular to the plane. So yeah, that looks a little bit better now. Okay, it's cutting it directly in half, which is what I want. Okay, cool. So yeah, that's what we got. And what we can do now, I'm not going to directly show you guys how to do this. But we were going to save all this stuff as an STL individually, and we'll go ahead and print it. You know what? Let me actually save all those as an STL. So why don't we do that? Oh, you know what? Going ahead of myself. So what we will actually do next is check on the mass properties and just make sure our center of gravity is appropriate. And we're gonna do a gear mate. Okay. I'm also checking my fan blade here. It's possible to change the geometry of the fan blade to where it will whack into that bolt. So if you've done that, then you might want to just change your fan geometry a little bit to account for that. Okay. But I'm forgetting an important thing here, and that is that I want to do some gear mates. Okay, first, just to make my life easier, I'm going to make that guy transparent. Okay, and then what I'm going to do for both of these gears is I'm going to make it so that uh, the gears are somewhere in the middle like that. Okay, and for this one as well, I'm going to make sure that it's right in the middle like that. Okay, now I'm going to go ahead and edit these individually. So we're going to go and we're going to edit part. Okay. I'm going to sketch on that plane there. Okay. It's going to have me go normal to it. And then I'm going to make a circle of 18 millimeters. Okay. I'm going to make you smart dimension 18. Okay. And that's going to represent the pitch circle for that smaller gear. All right, I'm going to do that same thing for all the gears. So if I show all the sketches, I can see that that sketch I just made. All right, now I'm going to get it again, edit this gear. It's not enough to make a sketch directly like in the assembly. I have to go in and edit the part and then click the surface and then make a sketch on it. And I'm going to do the same thing for this. So this one is going to be 72 millimeters in diameter. 72. Okay, cool. Clicking out of that sketch and out of the part. Oh, I guess I need to go back into the part. I'm sorry. Uh, let's edit the part once more. And of course, we need to do that circle on here. Okay, so these circles are necessary for doing the gear mate. I'm not sure if that was made clear. So we're gonna again go 18 on this one. Okay, and we will do smart dimension, and we'll make sure that's 18. All right, great. We're gonna go exit out of that. And we will actually finally exit this part as well. And now we have that circle. All right. Finally, we need to go into this part and just add the single circle for its pitch circle. So we're going to go here and we're going to do pitch circle. We're going to make this one go to 72 millimeters once more. Okay, great. All right. So now I'll again exit that part. Now what we can do is we can do our gear mate. So we're going to go mate. It's helpful to have the gears like sort of meshed in the proper position so that it all looks right. But we're going to go over here to mechanical mates and we're going to go down to gear and we're going to do that one and that one together. Okay. And it should get the ratio. Let's double check. So we're going to click check on that one. And let's just check by rotating. Oh, yep, that looks pretty perfect. Okay, so those are meshed together. So now we'll get it so that the other two are meshed together. I'm just going to move this back to where it's nice and square in the middle of that gear. And we'll do another mate. Uh, let's delete that. Let's go to mechanical. Not rack and pinion. We want gear. Gear mate. And we'll select that circle and that circle. All right, so we have gears. All right. I guess we'll actually do two more things in this assembly. First thing we're gonna do is we're gonna just check the CG. That'll be really quick. So if I go to evaluate, I could go to mass properties and I can find a really quick CG. Okay. And I can just make sure that it's not going to be positioned directly over or that it will be positioned directly over the base plate here. Okay. You know what I'm going to do actually too? I'm going to uh gear fan stand. Let's apply a material so that that is accurate. So I can do will it let me do ABS is probably close enough. So for all those guys, the gear fan, we're just gonna make them ABS. So uh gear fan. Oh, is that? Oh, it's because those are individual parts. That's why. So I can make this material ABS, and same with this one. ABS, and doing it to all the other options just so that we can check. Um, so this is the crank gear small, yep. And we will make it again, ABS. And same with this guy, ABS polycarbonate. Okay, cool. So now all the materials I think should be specified. Let's see, these say they're stainless steel. Aha, but they're not specified, even though they say they're stainless steel. So We can, it doesn't have a stainless steel here in the call outs. I can go to more options, I think. Uh Customize menu. Oh no, I don't want to do that. I want to go edit material. So like, there's a lot more options here. Uh, so let's see, we can go down to uh steel, stainless steel, not cast stainless steel. Uh, I guess it doesn't super matter what type, but we'll just do this 316 stainless. And this is now too big for me to see. And we will, come on. God, come on. Try to just move it over to my other screen and we will apply that. Okay, cool. And hopefully it does that for all of them. Apply and X out of that. Yep, so I made that 316 stainless. And I hope it does the same to all the other ones. Great. Um, so this one, yep, 316 stainless. And now let's see, will it do it to that one? Nope. Let's make this one also. Uh, yeah, we can make this one. We could just honestly make it just a plain carbon steel. It'll have a very similar density in the end of the day. So that's good. We've now specified all the materials for all of our components. Even though they're not exactly accurate, they'll probably give us reasonable masses. So let's take a look at the mass properties. And we can see, again, the pink CG. Yeah, it does look like we're firmly underneath the base here. So that should all be just fine. Okay, cool. So now we'll try and do a motion study just to really quick see what's going on and double check our calculations, I guess. Um, so let's see what we got here. So we're gonna go over here. I guess the first thing we're gonna do is gonna apply a rotation. Well, actually, first, instead of animation, we're gonna go to motion analysis. Okay. Um, and then let's see how we're gonna apply motion. So make sure that's the motor one. Okay, yep, that's the motor one. Okay, so we're gonna do rotary motion, and we're gonna click on that guy there. Okay. And we're gonna set that constant speed to 60. Okay. And we're gonna, yep, I think that should be good. Linear motion looking good. Okay. So yeah, let's take a look at how that runs. Yay. Okay, cool. So we can see all of that moving. I can have this repeat for us. So I can go like that. Okay, cool. We got that. All right. And it seems to reset us. So the way we do that, orientation and camera, uh, we should disable key view creation. Okay. And now we should be able to run it. Oh, it still does that. Sorry, I don't want it to do that. So we're going to stop that. Uh, disable key view creation. Um, disable playback of key views. There we go. Now it just holds it wherever we had it. Or it should. Yep, there we go. So now we can move this around and it won't reset our view. All right. So another thing we could do is figure out what the RPM on the other one is. So let's see. So let's do some results. So we could do results, select a category. We're going to do velocity and acceleration subcategory, angular velocity. And I want to see what the angular velocity of, oh, not that one, this component. So we're going to delete that. Yep, that component. And then we are going to have it do plot versus time, and we're going to do angular velocity in the around the z direction. Okay, so I could see the z-axis is the one that goes along the like sort of shaft direction. So we're going to do the z component on that one. All right, and we're going to click check, and we can see that yeah, uh 5,760 degrees per second. So let's see. 5,760 divided by 360. That's 16 revolutions per second. 16 times 60 is 960. You know what? Actually, let's go down so we could actually edit that definition. Um, oh, I just realized my face was not over here. I could put my face back over there. Um, so we can do the results. This one plot, we can edit that. Let's see if I could change the units. Um, how come I can't do let's see if I can't do the units. Um, why wouldn't it let me change to RPM? I guess if I change the base units of the document. But anyways, so we have the RPM, we have the time. Obviously, it's constant because that's what we set it to. So yeah, pretty good. So we have our motion study, and that looks great. So yeah, I'll just play it a couple more times just so you get the idea. It's spinning pretty fast, and I don't think you're quite able to see just how fast it's spinning. So let's see, can I slow it down? But that's going really slowly, and it's kind of jumping a little bit. But anyways, that's our motion study. So now what I'm going to do after all that is done, let's go back to the model view so that everything looks a little bit more simple. Uh, and now let's go and we'll save everything as STLs. Okay, so I'm going to go ahead and I'm going to open all these parts individually. And we're going to quick save it first and then do file, save as, save as. And then we're going to do STL, save. Yes. Okay, cool. Now we probably don't need this one anymore. Can I close you? There we go. So we're good on the gear stand. Let's take that one. Let's open it up. And now we can go save as. STL, save. Yes. And we'll save that one as well. Okay, cool. So we got the crank just working our way up. Let's get the compound gear next. Open that. All right. And now we are going to uh file well, oh, I don't want to print, sorry. Come on. Save it and then save as. And then we will make this an STL, et cetera, et cetera. I might fast forward through a lot of this. There we go. Or you can too. So and now we'll get our fan. Okay, cool. And then now, oh wait, no, I don't want to do that. I want to open up the fan. Okay. So now we're going to open up that subassembly, the gear fan video. Okay. So now, yes, I want to. Yes. Okay, it's been modified. Okay. Let's save all. Okay. So now this is where it gets a little bit tricky. So this we want to save this as like a solid piece. Okay. So I'm gonna go file, save as, save this as, a part file. So we're making an assembly into a part file. So SolidWorks part, Gearfan video, um, part file. I'm just gonna name it that so I know. Um, there we go. So hopefully it should open that one up. Will it? Okay, well, maybe it just saved it. So let's file, open, part file, open. Okay, cool. Do I want to proceed with feature recognition? No. So when you did that, when you do that, it kind of saves it as these individual bodies, which we don't really care about so much. So let's get out of that. Which we don't really care about so much. So we have this Gearfan video part file, and we're going to try and save this as an STL finally. Okay, and then we should have all the STLs that we need. All right, cool. So now let's go into Cura. So I'll open up Cura really quick, and we will show you how to slice all those. All right, so next up, we're gonna start to print these things. So open everything up in Cura. We're gonna do File, Open Files. We're gonna go to all the Gearfan stuff. Open that up. Okay, cool. So let's see how many of these we could fit all in one build platform. So I'm going to quickly rotate that one around. All right, that's looking pretty good. Let's maybe get it in the corner. We might not be able to fit this one in the same one that we put both of the gears in. But oh, looks like we might get close. So we're going to rotate that around. There we go. And we're gonna do that one around like what? No, not that way. Gonna go around the green direction. Okay, cool. Making that flat on there. All right. So you might ask, like, wouldn't it make sense to maybe do the fan the other way round, because it looks like there's a little bit more gap underneath this way than there is, from the bottom, from the top there to where the fan is. Um, so yeah, for that reason, yeah, there would be less support material if we like flipped it upside down. But the problem I found with this first prototype here, was that if you did that, I don't know if you could see on the camera here, but the top fan there wiggles around quite a lot. And I think that was as a result of it getting taller, and you lose sort of a little bit of definition, I guess, the higher up you are. So the bearing pockets are going to do a lot better when they're very close to the build platform. All right. So, yep, looks like we could probably fit all these in one build. We'll try and get that one from underneath that one if we can. Looks like it'll, yep, be able to go just like that. And stick that one over there. So yeah, that looks pretty good. Um, Annoyingly, there will be some support, I guess, directly on this other part here, directly on, I guess I should say, the stand, but you'll be able to sand it off. It's annoying to like have support like on top of something. Usually it like doesn't break away as easily because it's only meant to break away from things that are like above it. But anyway, let's move that guy slowly, short a little bit over. All right, that looks fine. So let's take a look. We could make the quality basically the same as what we normally do. Point 0.2 will be fine. I mean, you could really honestly go bigger than that. The gears are gonna meet with like a lot of like slop and backlash. So, it doesn't, you can have it be a little bit thicker, and it could be a little bit lower tolerance, and it'll still more or less work. Um, Speed is all fine. You know me, I like to slow things way down on the beginning so I can make this 10 rather than 30. Take a little bit longer, but I think it's kind of worth it to do that. Let's go down. Yeah, so we'll try the tree support. Overhang angles greater than 50. That might work, especially for the propeller. That's probably a good way to do it, because there's like going to be a lot of support area, and it's going to be way easier to move the true support if indeed it does succeed. Uh, oh, and let's bump our material up to 210, or yeah, our temperature up to 210. Build plate to 60 is fine. And skirt is going to be fine. Let's do a brim. Um, might not be strictly necessary with a lot of the surface area that we have, but specifically for the propeller, it's gonna maybe need a brim to stick to the bottom there. So let's slice that.
Here, it looks like I put time lapse here.
Okay, cool. So it says it's gonna take 15 hours. Let's preview that. So yeah, it looks like underneath the underneath this guy, it's going to save some material by not having like the full support. I will say that some of the taller tree supports um, sort of fail. So I don't have high hopes for these long ones. And also, I'm not sure that that's really needed. If you wanted to, you could do a bit of support blocker or something like that. But largely, I think this is going to be just fine, and it should hopefully go pretty successfully. If it fails at any point, hopefully you'll fail after you get one or two of your gears out of the way. If you really wanted to err on the side of caution, you could print these individually, but I think it's definitely going to save time to print them all at once. All right. So yeah, next what we'll do is I'm not going to show you the process of starting the print. You should have already gotten that with some of the other videos, but I will show you guys how to assemble it, and we'll see how it works. Another thing we'll do in the settings is just make sure we adjust our horizontal compensation. So I'm going to leave this at minus point 3, which is or yeah, you know what, 0.25. Um, yeah, that's what's appropriate for my particular Ender 3. You could choose whatever you want on your Prusa, or sorry, you could choose not whatever you want. You could choose what best works with your Prusa. So you'll reference some of your other labs, and you'll get, you'll use the measurements that you got from various parts. And you'll be able to gauge what sort of horizontal expansion you'll need for this. Okay, so for me, I'm gonna end up like printing this on my Ender, so or at least that's the one I know these tolerances of, so I could just put that horizontal compensation in, and hopefully it'll make things to the exact right dimensions that you want them to be, or at least close enough. Once the parts are all printed, we're going to go about assembling our gear fan assembly. Okay, so the first thing we're going to do is we're actually going to take the tap. Okay, so this is an M4 by 0.7 tap. Hopefully you can get that to show up. Okay, yep, M4 by 0.7. Should be able to see that. Yep, there we go. So we're going to use this. We're going to grab our tap wrench. All right, we're going to put the corner of the end of the tap into that little V groove there. Going to tighten that down. Okay, now we're going to try and go in as straight as possible. It's going to require you to push a little bit. These holes are already tapped, so it'll be easy for me, but you're just going to go ahead and thread these holes. Okay, so threading it like that, what I'm going to do is after I'm established in the hole, I could go in a little bit, come out, break the chip, in a little bit more, come out, break the chip, etc. until I get all the way through the material. Okay, and I make sure that I am well through the other side, significantly out, so something like that I could definitely see the end and it's gone well past. Okay, that's what we were going to want. Trying to go as straight as possible, although if you're a little bit off, it will probably be okay still. Mine are not exactly perfect. All right, so taking this all the way out. Next, what we're going to do after we've tapped all those, again, I've tapped all those, and I'm not going to go over tapping all of them for you. But yeah, you wanna make sure you do that to all 3 of those holes. Okay. Next, we'll use the telescoping gauges. So if we remind ourselves how those work, so if I loosen this thimble down here, you can see these extend. Okay, this is the smallest size that we have. So we're gonna press them down and then tighten the thimble so that they're all pushed in as far as they'll go. Then what we're going to do is we're going to stick it in here. We're going to extend it, okay? And then we're going to tighten down once more, okay? So what we should really find is that this is, you know, we modeled it to be about 0.001 inches, or sorry, 0.001 millimeters undersized, okay? I think the actual number was 0.0008 millimeters, okay? Which is 0.8 microns, okay? So let's see if we can measure what it actually is, okay? So let's see. So let's see what we got here. Tightening this down. Tighten that until it's touching. Okay, cool. Let's just make sure we have an accurate one. All right, I will lock that out there. Okay, so let's take a look at this one. So I see we are just a little bit above the 30. Okay, so I see 0, 5, okay, and then 6, 7, 8, 9, the big ticks, okay, and then I see 1/2 tick as well, so one of the small tick marks, okay? So that's telling me that this is 9.5 plus 0.3, so that would be 9.80, okay, because it's 30. If it was 31, it'd be 81, okay? So that's 9.80. And the middle one there is 5, 9.805. And you could see the 5 on the barrel there lines up best with its given tick mark. Okay, the other ones don't line up quite so well. Okay, so my final answer here is 9.805 millimeters. Okay, so we are kind of well undersized. We are not going to, in this particular case, worry about, you know, making them a little bit wider. Basically, we'll just press them in as is. The elephant in the room for this particular assignment is we used cast iron / steel housing specifics. Okay, so, and what it recommends in the ASME specifications is that if you're using plastic, you'd use a little bit more of an interference fit than what you would normally do. It doesn't really specify that, especially not for 3D printed plastic. But yeah, if it compresses like a little bit more than we've specified, that is perfectly okay. Okay, so now what we're going to do is we're going to attempt to place all of our bearings in. Okay, so I'll go get a hammer. To press these in, we're going to use a little bit of persuasion. So you could use, I might need a flat plate as well. We'll see. Oh, no, I was able to get that in there pretty easily. A couple mallet taps, looks fine. Okay, and I'll do this same thing to all the other geometries. Trying to get those as flat as possible. All right, this one's going to be a little bit tricky. Okay, I'm actually going to use the edge of the table. Sorry if that's a little bit out of shot. Okay. Okay, beautiful. That one's in there like that. Okay, let's get this one in. Okay. Come on, get in there for me. There we go. So that bearing is seated. All right. All right, so the last two bearings, so we got both bearings in this one, and we got one of the bearings in both the fan and the crank. Okay, so now the other bearing needs to go down in there, and I've just prepared for us this little aluminum piece. Okay, and so we're gonna slide our bearing, hopefully all the way down in there. Okay, and then we're gonna again use our hammer, and that felt pretty good. Okay, gonna be kind of hard to tell if that is successful, but we'll know in just a minute here. Okay, so let's do the same thing with the other side. So again, sliding our bearing down in there. All right, and let's give that a whack. Okay, cool. And now yep, I see the hole all the way through there. So that should be pretty good. All right, so let's try and make sure that our bolts go all the way through. Okay, not quite going in straight. Sometimes they're a little tricky. Okay, let's make sure, let's actually check it on the back side. What you guys will do is you'll make sure you check that that they all line up, or sorry, that all the bolts are toleranced correctly. So yeah, let's hammer that down a little bit farther. Looks like it wants to be a little bit more flat. Okay, I think that's got it. Now let's try to go this way once more. That's not quite fitting. All right, let's try and hit this one into place a little bit better. All right, that might have it. Okay, so that will go in. All right. All right. So yeah, after the bearings are pressed, okay, the next goal will be to get the shoulder bolts in there. Okay, so what I'm gonna do is I'm gonna stick it in the end there, and then we'll use the same piece of aluminum to hopefully push the bolt out as far as it needs to go. Okay, so you see that I can sort of see the end of where the shoulder is going to start. Okay, so now I could take this guy, I could grab my Allen wrench, I could stick it all the way into the hole there, and I can start to tighten up the bolts. Okay, so yep, I'm tightening that down. You can see it's going into there. Okay, great. So that feels a little bit sticky. I'm just gonna loosen it just ever so slightly. All right. Oh, that's loosening itself all the way out. Don't want that. Okay. Just a little bit tighter. Okay, that feels pretty good. All right, it definitely moves, and it'll move more and more as we work this thing, as we work it out. Okay, so next I'll put this gear in. Again, the small gear goes towards the end there. Let's also make sure that our bolts can go all the way through. Okay, great. Looks like it can. Now we'll tighten this one in here like that. Okay. Now let's get it nice and tight. Okay. Yep, there we go. All right, looking pretty good. So we got those two. And now finally, we'll try for this one. All right, this one, let's just make sure both of those are seated. Okay, that feels pretty good. So let's see if the shoulder bolt will go through. Oops. Oh, looked like one of the bearings fell out. Let's try that again. Let's make sure the bearing is nice and seated. All right. Pushing that in. All right. Let's try and push that one in there. There we go. As you can see, that's gone through. So let's just, oh, there we go. Yep, it's definitely all the way through now. Okay, cool. So now we'll go under with this one. We might need to have it pushed in from here. There we go. And we're going to tighten that one up as well. All right, great. So let's give this a shot as soon as I tighten that all the way down. All right, it's looking pretty good. So yeah, you'll need to work it in a little bit and get it to like work a little bit smoother, like tune how tight everything is. But largely that is a working gear train. All right, so all the gears are meshed. All right, looks like we have clearance with the bolt like we should have had. And they all look pretty good. So yep, that concludes this video. Yep, thank you for watching.